Hello, my name is Kuncheng. This is homework 10 problem 2 presentation for the probability and stochastic process course. And for the second problem, it provides several property of the stochastic process, and from the lecture notes we need to show the definition and discussion. And for the first one is the WSS is wide sense stationary processes. And for the definition is a, the stochastic process is called WSS if its means is constant and the autocorrelation is a function of the time difference. For this one, it's very useful to analysis stochastic process because WSS only uses mean and autocorrelation. They are much easier to get than second order density. We can analyze a lot of things just according to the mean and the autocorrelation. Like we can do the state estimation and the parameter estimation and the prediction in mean square sense. And in this course, we don't care too much on the specific value of the stochastic process. We just do the easy analysis, and also we see that when the input is WSS process, the output of the stable system is also WSS. And the second one is independent increment. The process means xt1 minus xt2 and xt3 minus xt4 on non-overlapping interval are independent. For this one, we can know it exists many examples for stochastic process, like Poisson process. We can review the property of the Poisson process, and the random walk and the Wiener process are independent increment process. We can see it is or exists the property include the according to the xt1 minus xt2 on and xt3 minus xt4 on non-overlapping interval. So that's it. And see, the third property is the Markov process. We say that a process xt is a Markov process if the past has no influence on the future when the present is known. And we also can easy to get the Poisson process, Poisson impulse, semi-random telegraph, random walk, and the Wiener process are all Markov process. We can easy to get from their function. So, and we in real world a lot of process have the Markov property, and that's it. Let's see the fourth one is normal process, also can be called Gaussian. And a process xt is said to be normal if the random variables xt, x2, xtn are jointly normal for any n, any t. That is we have the function fx and x1 to xt, t1 to xt, and we have the function the 1 over the blah blah blah, a lot of things, and we have the matrix for the x and for the x underline and a lot of things. And for the discussion, the statistics of the normal process is completely determined in terms of the mean and the autocorrelation. In general, the mean is a function of the t, and for this course, in this course, we classify linear process as one example of the stochastic processes, and we classify normal process as a property of the stochastic processes. And for the fifth, a process is said to be a straight sense stationary process, means SSS, if its statistics is not affected by a shift on the time axis, and we write it by a function like this one. So if we have this one equal to, if we plus the same interval in the different time, and this condition is hard to meet. And for the sixth one is white noises. For the linear process WT, if we wish to discuss its derivative Vt equal to derivative Wt respect to the time, we have the mean Vt equal to 0, and we have the autocorrelation equal to alpha times delta T1 minus T2. And for the discussion, because the Wt doesn't have derivative, and for we use the Vt equal to derivative Wt just as a notation. When we need to do further discussion, instead of Vt dt, we use the dWt, and Wt is a continuous with a probability 1. It has a differential dWt, and Vt equal to dWt is a Gaussian white noise with 0 mean and impulse autocorrelation. And the stochastic process Vt is said to be a white noise if the mean equal to 0 and the autocorrelation equal to Qt1 times theta T1 minus T2. And for the last one, a stochastic process Xt is said to be a mean ergodic process if the function satisfy this function in mean square sense. Because in this course we just discussed in mean square sense, so this situation only happened in this condition. So for other condition we need to discuss and consider. So that's it. Thanks.